Yo,
Monaco here.
Yanar here. Oh, it's getting late.
Yeah, it is.
Yeah.
Last video in our atomic theory units,
Hallelujah.
we're going to describe how electrons can produce colored light through their excitation and emission.
This is the truth. And I think we're going to start with
Vocabulary and learning targets.
targets.
Of course.
I can explain how electrons behave around an atom to create colored light.
beautiful. I love it.
Ground state electron configuration is how you find the atoms when they relaxed. It follows the normal filling order, 2, 8, 8, whatever. And these are the values that you find on the standard periodic table. These are all ground state electron configuration.
Right. So if I deviate from that, it is now excited in some way. So an electron jumps up a level and the filling order gets rearranged to show that the electron is somewhere else now.
Mm-hmm.
Good?
Hey, okay. Yanar?
The absorption spectrum is a map of the absorptions that occur as the energy added is increased.
Yeah, you see, there's those, right? The colors that are, right? They're gone.
Let me simplify.
Mm.
Certain elements, because they have a specific number of electrons in certain orbitals, absorb very specific wavelengths of light.
Where those black lines are,
We call that the absorption spectrum. We show the whole spectrum, and the lines that are missing are the specific wavelengths in nanometers of the light that element is absorbing as its electrons are jumping up to the next energy level. You can't
Right.
see that light because it's going into moving an electron from one spot to the other.
correct. And then the next piece, same picture, is the emission spectrum. And that's that lower one. This is the light that has been emitted out. And notice those are the colors that should be in that top rung, right? And it emits that back out when the electron falls back down to its ground state. The energy it absorbed exactly is re-emitted in the form of light, and it will be that color. And there is another fingerprint, if you will. Every atom's is different. And we
Yeah.
get to do a little bit of this in lab, right?
Yeah, absolutely. This is the lab note this is speaking of. And each spectra is unique to each atom, just like a density is unique to each substance, right? The emission spectra and the absorption spectra is unique to each atom. It can be used and is used like a fingerprint for scientists, astronomers to identify elements in objects that are very, very far away, and all we can see is their light.
Yeah, and that's what that is actually practically used. You can take the light coming through the telescope or through the spectrophotometer, and you can see which elements are going on in that light, which will tell you what stage of life the star is in.
Mm-hmm.
Because it take a hydrogen, slam it together, we got helium.
That's the last unit.
I know,
He's
I'm
getting ahead of
foreshadowing.
himself. I know.
But there's real use for this stuff,
It is.
and it's kind of, I think, kind of wavy that we can figure out where that
Wavy
star is in form of, in terms of its life
because of light
cycles.
waves, right?
Yeah, and that's kind of neat.
That's it. There's not much to this particular video.
No,
And
you just need to know
Mhm.
that when the electron falls back to its ground state, it gives off what?
energy,
In the form of
light.
every time. And
It's
that's
called
the key.
a quantum of energy. Hence the quantum theory and things to that.
I don't
effect.
remember a Regents exam that didn't have a question about that.
Yeah, which of the following examples is considered to be in the excited state? It shows you 4 electron configurations. Or when an electron returns from the excited state to the ground state, what happens? Or how can you know that or it'll show you a bunch of emission spectras and say which 2 elements are in the mixture. Okay, that kind of stuff.
Yep. So something from this video, even though we went really fast, makes it seem like it's not important. We're telling you right now, it's actually going to come around. So we got to have a little bit of practice and make sure we understand it.
All right, kiddos.
See you.
Thanks.
Good unit, by the way.
Awesome. Well done. Gotta go home and make